Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We continue in this video our look at inheritance, and also we're continuing to look at our simple example of shapes. So in the previous example, in the previous two videos, we built up this example of having a shape as a supertype, and we made some subtypes of it. And then we looked at some of the details of how we can override methods and make methods abstract. Our shape, if we look here, our shape has an area and a perimeter method, as well as a color and a draw. And last time we overrode the area and the perimeter, we actually also overrode draw. So why don't I go ahead and copy that and put it down here, just so that our figure matches what we have in the code. However, our draw doesn't do anything currently, and as soon as I start to put in the draw, we're going to run into another problem. And so what I'm going to do in this video is put in the draw and look at the problem that runs into, as well as trying to find ways to fix it. So I guess in a sense we have our draw in here. Our rectangle has a draw that draws a rectangle, and the circle has a draw that draws an ellipse. However, if I come in here to my main, and let's just real quick see how fast I can set up a little panel that will draw these things. Val frame equals new main frame, title equals, I'll call it inheritance, Control Shift O, contents equals new panel. Oh, that's right. And this example is going to show you something else too. So I bring up a mainframe and I make myself a new panel, and Control Shift O to import the Java Swing panel. And at this point, you might have an aha moment if you watched the videos or read the book from the first half from part one, because you have seen override before. Okay, we used this here the last time that we wrote paint, and you might look at this and go, but there's no inheritance, there's no extends. There is no extends, there is inheritance. I will type in the rest of this. So let's set paint to color.white, g dot fill rect 0, 0, size dot width, size dot height, and then let's do r dot draw to g and c dot draw to g. Okay, once we have that, frame dot open. Let's see if that is enough to make it run. Actually, wait, cancel. Two things I want to do here. Not in the contents. At the top level, preferred size equals new dimension 200, 200. So I'm going to make it a fairly small window. Import the dimension, and center it on the screen. Okay. Now let's run this, and it prints, and oh, I know what my problem is here. Now I wanted that preferred size to be, the preferred size should be inside of the panel, because I want to be setting the preferred size of the panel. Okay, and that wraps around it. You see no rectangle and no circle. We'll come back to that. But before we do, let's address the fact that this looks like I'm just making a panel, but I somehow have this override in here, and as we saw, when we wrote the code from the first half of the book, we need it. I have to have override there, otherwise this doesn't compile. And it's actually, oops. Let's do that. We'll save. And if I hover over, it says that I am overriding the Scala swing component paint, and that I need to put the needs an override. That's exactly what we were having earlier, where I had to put override on my area and my perimeter. But there is no extends keyword here. So what's going on? Well, it turns out this syntax, where you say new of something and then you follow it with curly braces, creates an anonymous subtype. So I'm actually creating a new class here, and that class has a name associated with it, but it's not one that you could type in. And so effectively this class is anonymous. It does not have a name that you are allowed to refer to, but it is a subtype and it is doing inheritance. This is one of the things that I love about using Scala here is, for example, in Java, I have a very hard time, in fact it's nearly impossible, to teach the Scala GUI and graphics libraries without talking about inheritance first. But in the Scala version it's very natural and implicit, and so the idea that, oh, I make a new panel and I put a body on it, that just makes sense. And the only thing that was challenging was that override keyword. But now hopefully you can understand that. Even here for our mainframe, I am actually making a new subclass of mainframe, and I am setting stuff inside of here. All of this is going in the body of a new class. I could, if I wanted to do this in a longer form, I could have said class myFrame extends mainframe, and then put all of this stuff up inside of here and said frame is a new myFrame. That would actually be basically the exact same code, except that I'm giving this a name. And if I were going to use this one type multiple places, I want to give it a name. However, in this case, the only place that I'm using it is right inside of here. And so I'm perfectly happy making it an anonymous class. Okay, so now that you've seen that, let's go back to the fact that I have no circle or rectangle. Now, we could go and ask, well, maybe it's just not drawing. Okay, well, actually, we can verify that real fast. Print line, draw the rectangle. And we come back here and we run it again. Draw the rectangle. It didn't just draw it once, it drew it twice. So that's not the problem. This is being called, it is drawing it. So why don't we see it? To answer that question, we have to realize that, so we have to look a little bit more closely. So we set the paint to white. We fill the entire background with that white, and then we call rectangle.draw. Well, what does rectangle.draw do? Well, it draws a rectangle of the appropriate width and height, but it's drawing it in the same color that we had here, and similarly for the circle. So this actually, when I'm running this code, it is drawing a rectangle and it is drawing a circle. It's just drawing them in white on top of white, so you don't see them. And so what do we need to do? Well, okay, we made it so our shape does have a color in it, after all. It has this color right here. So I should be able to have, the first thing that happens inside of here is g.setPaint to color, right? That's the obvious solution to this problem. But that has an error. The value color in shape cannot be accessed in rectangle. Why is that? Because shape is private. Okay. Remember, private data only exists inside of the scope of that class. So this val can only be accessed from here to here. Rectangle is clearly outside of that scope, and therefore we cannot access color. So how do we fix this? I'm going to talk about 3 different ways that we could fix this. Method number one. Okay. Method number one, okay, so I'm going to talk about 3 good ways to fix it. I'll show you one that would just be kind of silly, and that would be to make this public. Okay. Especially if I have any reason for the color to not be public, you should go with that reason. Making it public just so the subtypes can access it is a horrible idea. And it turns out there is a visibility that gives us exactly what we want here. I want this so that not everything can use it, but the shape can use it, and so can the subtypes of shape. And so for that, there's a visibility called protected. And you see when I save that now, my rectangle has no problem. And so if I go back over here and I run, there's my little rectangle. There's actually an ellipse on there too. How about we make our rectangles, how about we make these things bigger? Now that I'm actually drawing them, it kind of makes sense to have them be a reasonable number of pixels. You can see the rectangle, you can see my circle. However, my circle is not being drawn in its color because I don't have a line like this inside of the circle. I guess we could just copy and paste so that you can see that this code indeed does what we want it to do. And in this case, this was probably the solution that I would go for. It's fairly simple. I think I can come up with good arguments for why the subtype should be allowed to access the color. And so making it protected seems like a perfectly reasonable thing to do. Now, one thing to keep in mind is that protected data in some ways isn't really much more secure than public, because you have no control over who inherits from your class. So just that's something to keep in mind. In this case, it's a val for color, and color is immutable, so really I could probably make this public and it wouldn't hurt me. Definitely I can make it protected without having a problem. One of the things about this, though, is this approach only works if we're just talking about a simple piece of data. And what if, in addition to having this data, I wanted to increase the functionality? In some ways, I did duplicate a little code. I have a set paint of color here and a set paint of color here. What if instead of just being one line of code, there was 5, 6, 7 lines, 50, 70 lines, who knows, that I wanted every draw method of every shape to do before it drew itself? Okay. That's not an unreasonable thing to expect to have happen. There might be a significant amount of setup that we want for each of the different draw methods to do. Well, in that case, just changing the data to protected would not give us what we wanted. So I'm going to take this back to private and look at another way of dealing with this. So one other way of dealing with this would be to make it so that the draw method in the shape actually isn't abstract. Make it so it does something, but all that it does is the shared code. Okay? So the shared code in this case is setPaint, g.setPaint of color. And I should go back here and fix my spacing. So I set the paint on G to be color, and now I don't want this to happen here or here, because I can't access that. But what I want to do, the first thing inside of here, is I want to call the draw method in the supertype. Now we've overridden it, so we're getting our own draw method, but I might want to have it so that I call my own version of draw. Or so I call the one that's in the supertype first. And this would be kind of a contract between the supertype and the subtypes, that all of the subtypes are supposed to call what happens in the supertype first. The problem is, if I just go draw of G here, well, it might not be immediately obvious what this is going to do, but this is an infinite recursion. Because when the rectangle calls draw, the first thing that draw does is it calls draw, which calls draw, which calls draw, which calls draw. Clearly that's not what I wanted to do. I wanted to somehow call shapes draw. And there is a way to do that, and it's to use the keyword super. So the super keyword refers to things in the immediate supertype. So in this case, if I want to get hold of something that I have overridden, and of course if you haven't overridden it, you don't need to do this because you can just call it directly. But if you have overridden a method or a variable, then you can use this to call back directly. And let's put one in circle, and let's verify that this does what we want it to. Okay. We still get the same output. In some ways everything looks fine. This works. Now, pros and cons of this. In some ways the con is the fact that it's very easy to leave out this line of code. The pro is you could leave it out. So maybe there were a few shapes that weren't supposed to do whatever your introductory stuff was supposed to do. Well, then you could have them skip that step. Okay? But what worries me more with this solution is the fact that someone's going to create a subtype later on. They don't go and read the documentation. They don't read that they're supposed to call this, and so they don't put it in, and that causes an error. Okay. So, what's the alternative to this? The other thing that what I would consider doing here would be to leave draw with an implementation, and then I'm going to make a new method here. I'm calling it, left out the word def, I'm calling it subdraw. Okay. Now, I'm making it protected. Subdraw is basically the draw that's supposed to go inside of the subtypes. Okay. And my draw method here is going to, the idea is that when other code uses a shape, they call the draw that's on the shape. In fact, most of the code won't have access to subdraw because subdraw is protected. Okay, so here, this use of protected, I am sending a clear signal to my subtypes that they are the only ones who should be dealing with this. Outside code can't touch it. And because it is an abstract method, you can see we have an error over here, because now I have an abstract method that's not being implemented in the rectangle or in the circle. So in order to get rid of that error, I have to write subdraw. And now what my draw does is it does whatever preamble code I had, the setting the paint, and then it calls the subdraw, which is unique to each of the subtypes. So in order to make this work, actually it turns out I have most of what I wanted. Instead of overriding the draw method, I want to override subdraw. Okay. Another thing, if I take this approach, especially if I want to make it so that every subtype has to go through the draw method, has to include this, I don't want to allow them to override my draw method. Okay. They are stuck with this draw method forever and ever. And I want them to be. I want them to be forced to use mine. But as it stands right now, so if I go ahead in here, override def subdraw G graphics 2D, okay, now my circle is happy, but I put in my own draw method, and I could do unwanted stuff here. Once again, the supertype has no control over what types inherit from it, and especially if the supertype really wants to make sure that all drawing goes through its draw method to make sure that whatever code is run before subdraw always happens, then this isn't quite sufficient. So how can I stop my subtype from overriding draw? Well, the answer to that is a new keyword called final. So when you make a method final, what you're saying is subtypes are not allowed to override this. This is the final implementation of this in the inheritance hierarchy. There cannot be one underneath it. And so if we come back over here this causes a problem in our circle because it says, whoa, whoa, this is supposed to be final, you're not allowed to override it. To make it so that this is happy, I will get rid of the definition of draw and just go with the subdraw so it looks like what we have in our rectangle. So now subtypes cannot create their own draw. They are forced to create their own subdraw. I actually want these to be protected. Because I might not want them accessible from the outside world. So I have my, I have forced the subtypes to write a subdraw so they can't forget to do it. And I have also, through the use of final, forced them to kind of take part in my version of draw. Okay? And there are lots of types of situations where you want to do this. Final also has another usage. Instead of just putting it on a on the method to say you can't override me, you can also use final as a modifier on an entire class. And when you make a class final, what that does is it says you are not allowed to inherit from this class. Okay? This class is the bottom of the inheritance hierarchy. It cannot have any subtypes. Now you might wonder, why would you want to do that? And the simple answer is it deals with, in a lot of cases, if you have something that's immutable, immutable type should probably almost always be final. And the reason for that is because if you make an immutable type and you don't make it final, someone could create a subclass that was mutable. And then any code that assumes the immutability, if it gets past the subtype, it's going to break. Okay? So in order to enforce immutability, you really have to make it final so that you can't create any mutable subtypes of it. So let's go ahead and let's run this and see, sure enough, it still works. It does exactly what we wanted. For me personally, this is probably the ideal solution. Making the color protected was good if all that I really had was the thing about the set color, but it was still possible to forget to put in set color in these things. I'd probably remember it fairly quickly, but I don't like having a situation where the developer of a subtype has to remember to do things. If possible, I like it when the language, when the library and the compiler enforces that they have to do things so that they can't forget it. And so this solution, in my opinion, is fairly ideal. I have a draw method, and it is final, and so everyone is forced to use my draw method in all the subtypes. And I'm also forcing them to write a subdraw because I have a subdraw here which is abstract. It doesn't have an implementation, and so their subtype won't compile until they actually go and write the subdraw. This approach also means that if I wanted to do more than just set the paint here, if I can add whatever extra lines, and it will automatically happen in all the subtypes the way that it's supposed to. So that's it for this video. We will come back next time and look at when you should and shouldn't use inheritance, and also talk about that whole the mutable versus immutable stuff, because that winds up being significant in this conversation. So see you again soon.